Well, I would like to take the time to thank everyone for attending today's presentation. My name is Lance Zurich, and I'm the product manager for the Fisher Technic Education Division over here at Studica. And today I'm going to provide you with an overview of Fisher Technic's line of pre-assembled industrial simulation and training models, including the latest models incorporating new cutting-edge technologies. Now, over the years, I would typically begin these presentations with a discussion of the importance of STEM education, talking about changes in the manufacturing environment, and also talking about the growing need for highly skilled workers in the modern workforce. But as I think at this point, it's fairly well established just why technology-focused education is so necessary, I'm going to dispense with any preamble and jump right into the discussion of what Fisher Technic is and show you each of the current models in the simulation family. Fisher Technic simulation models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled small-scale models which are designed to replicate in both appearance and in function various automated robotic machines and systems commonly used in commercial manufacturing. Now, before we look at each of these models, though, let me provide you with a very brief background on Fisher Technic and what it's all about. Fisher Technic has been creating tools for teaching students of all ages how technology works for over 50 years, all based around their unique building system. Now, what makes this building system so unique is that unlike other popular construction systems where the components are designed to simply stack, with the Fisher Technic system, it was created with more of an engineering mindset. And what I mean by that is that the core building block in the system, as you see in the picture on the screen right now, is designed to enable attachment from all 6 sides. And because of this, it allows for almost limitless design possibilities. Now, many of the parts are designed to slide together and lock in place using a tongue and groove assembly method. And the hundreds of different parts available will also help technical builders to address very specific design needs. The Fisher Technic system was created in the 1960s by German inventor Arthur Fisher, who's noted for countless innovations used in the construction and the automotive industries. Mr. Fisher, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, prior to creating Fisher Technic, Mr. Fisher was also noted as the inventor of synchronized flash photography, and this was back in 1949. And a few years later, he gained fame as the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fisher Group, continues to employ thousands of workers around the globe, producing many variations of fastening devices used in building construction. They also produce numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of Fisher Technic building sets, whether it's those intended for the retail market or those for classroom use, has always been on helping to foster an understanding of technology. Many of the products offered by Fisher Technic for the education sector are subject-specific sets. And what we mean by this is they focus on different STEM-related topics, things such as mechanics, pneumatics, robotics, renewable energy, and so forth. Now, many of these sets either include curriculum or detailed teaching and activity materials. In most cases, students are asked to build a progression of models using the unique Fisher Technic building system and then perform various experiments which allow them to explore and understand key aspects of the subject being studied. The line of Fisher Technic simulation solutions, which of course are the focus of today's presentation, are something much different. This line consists not of kits, but of a series of pre-assembled small-scale models which replicate in appearance and function various automated robotic machines and systems. Models in the Fisher Technic simulation line include things such as conveyor belts, punching machines, 3-axis pick-and-place robotic arms, color sorting lines, and high bay warehouse storage systems. Now, besides these individual models which focus on specific automated processes, Fisher Technic also offers several variations of an integrated factory simulation model. These factory models consist of 4 individual workstations, a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with oven, and a sorting line with color detection that are designed to all work together as one self-contained material cycle. Now, we're going to look at all these models in detail, of course, during the course of this presentation. But before we do that, let me briefly outline some of the advantages of using Fisher-Technic solutions. First, Fisher-Technic simulation solutions allow educators to offer engaging hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. 2, the models once again are designed to realistically replicate in both appearance and in function common automated systems such as conveyor belts, sorting machines, robotic arms, and much more. Because the models are compact and in most cases tabletop size, they're not only ideal for use in the classroom or in office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. The next aspect is quality. Each Fisher-Technic simulation model is a hand-assembled, high-quality, German-made product. Each model is available in 2 versions. The first version is a 24-volt version, which is designed for use with industry-standard PLCs. Now, whether you use Allen Bradley controllers, Siemens controllers, or controllers from manufacturers such as Honeywell, Mitsubishi, General Electric, or others, you can control these 24-volt versions with the PLC you prefer. Likewise, just as you can use your choice of controller, you can also use your preferred programming language of the languages listed on the screen now. Now, please note, though, that with the 24-volt versions, in most cases, no PLC is included, and all programming guidance, as well as any power sources or other hardware, are the responsibility of the end user. Of course, this shouldn't be an issue, as these models are designed specifically for industrial users or for those who are teaching or exploring industrial processes involving PLC programming in a lab environment. On the other hand, for non-industrial users and for educators not versed in or familiar with PLC programming, there are also select 9-volt versions of these models available. These 9-volt versions ship pre-wired to Fisher-Technic's own proprietary robotic controllers, which are the Robotics TXT controller. And each controller is pre-programmed using Fisher-Technic's own RoboPro graphic programming software. The only additional component required with the 9-volt versions will be the addition of 1 or more 120-volt power adapters, as I will specify with each model. Otherwise, in most cases, these 9-volt versions should be essentially ready to use out of the box. Now, if you're involved in demonstrating or exploring IoT, which of course is the Internet of Things, besides the fact that many end users have adapted some of the models in the primary line of simulation and training solutions for IoT purposes, Fisher-Technic now also offers a special IoT-focused version of the factory simulation I mentioned previously, this one being designed specifically for exploring and understanding cloud control and what is sometimes referred to as Factory 4.0. In this case, the model is designed to be both controlled and monitored from a special web-based dashboard, and we're of course going to discuss this in more detail a little later in the presentation. Finally, Fisher-Technic simulation models are cost-effective. Now, if you've had the opportunity to look at any other hardware-based industrial simulation options that are available in the marketplace, you'll probably pretty quickly notice that the entry point for many of these products can easily be $30,000 to $40,000 or even much more. Fisher-Technic simulation solutions, on the other hand, start at just a fraction of that price. And again, they are compact, realistic, and high-quality learning and demonstration tools. So with that being covered, let's look at each of the models which are available. We're going to start off with the classic line of Fisher-Technic simulation models, and our first model is going to be the basic conveyor belt. And this is a transport belt with a length of 275 millimeters that is used to transport workpieces with a diameter of up to 29 millimeters. Multiple conveyors can easily be connected to increase the length of transport as desired. Components on this model will include an excess motor, a push-button limit switch, 2 phototransistors, and 2 LED light barriers. Dimensions of this model are approximately 14 by 10 by 4 inches, and it has a weight of just under 2 pounds. The model is available in both the 24-volt version with a multi-pin connector. This is 26 pins with a 2.54 millimeter grid as seen here. And again, the 24-volt version of this model, as well as all but one of the 24-volt versions that we're going to look at this afternoon, will require you to provide the PLC and the program. There is also a 9-volt version, which is connected to a pre-programmed robotics TXT controller as shown here. For this one 120-volt power adapter is required for operation. I will also mention that this and all of the models that we're going to look at today, for any of these models, you can find the specs detailed in the product listings found on the Studica and FischerTechnik.biz websites, as well as in our product brochure, which I will provide information on obtaining at the end of this presentation. The next model is a variation of the conveyor belt we just looked at, except this time with a machining station built in. Components on this model include 2 XS motors, 2 push-button limit switches, 2 phototransistors, and 2 LED light barriers. Dimensions of this model are approximately 15 by 12 by 7.5 inches, and it has a weight of just about 3.5 pounds. Again, it's available in the 24-volt variation with a 26-pin connector, a 2.54 millimeter grid as shown here, and the 9-volt version wired to the robotics TXT controller, which requires one 120-volt power adapter for use. The next model we're going to look at is an index line with 2 machining stations. This model features a U-shaped conveyor line consisting of a milling and a drilling station and 4 conveyor belt sections. Other components on this model include 8 XS motors, 4 push-button limit switches, 5 phototransistors, and 5 LED light barriers. The dimensions are approximately 19 by 18 by 11 inches, and it has a weight of just about 2 pounds. Again, it's available in both the 24-volt version with a 26-pin connector and a 2.54 millimeter grid for use with PLCs, and also a 9-volt version wired to the pre-programmed robotics TXT controllers, in this case, 2 robotics TXT controllers, and so you're going to need 2 power adapters for this one. Next up is a variation on the idea of a pick-and-place robot, which is the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses it to help it quickly and precisely position the work pieces it picks up in 3-dimensional space. The degrees of freedom for this robot are as follows. Axis 1 turns 180 degrees, Axis 2 can move forward or back 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components on this model include 2 XS motors, 2 encoder motors, and 4 push-button limit switches. Dimensions of the model are approximately 19 by 16 by 9 inches, and it has a weight of just about 6 pounds. And as with the other models we've looked at, this is again available in both the 24-volt version with the 26-pin connector and a 2.54 millimeter grid, designed for use with the PLC and programming of your choice, or a 9-volt version wired to a pre-programmed robotics TXT controller and requiring one 120-volt power adapter. The next model we're going to look at is the vacuum gripper robot. And for this one, we have a little video to look at. Now, as you're going to see here, the vacuum gripper is a 3-axis robotic model with a vacuum gripping device. The model being shown here is designed to, again, precisely pick up and position work pieces in 3-dimensional space. This model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, and a solenoid valve. The dimensions on this model are approximately 9 by 19 by 15 inches, and it has a weight of 7 pounds. The 24-volt version of this model, as well as all of the 24-volt models we're going to look at moving forward, each have a relay board for motor polarity reversal and both a multi-pin connector, this time 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the 24-volt version of this model, as with all 24-volt versions, will require you to provide the PLC and the program. We're going to let this play through here so you can just see the model in motion. And we're reaching the end of this one. Very good. Next, we're going to move on to the automated high bay warehouse, as you see in the picture here. In this video, you're going to see a model which features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays. And there you'll see 9 individual storage spots for the workpieces. Components on this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces along with the carrier trays for each. Now, I will mention that this model is a favorite among educators I've spoken with who teach PLC programming. And the reason for this is because it gives students a lot of very specific coding tasks to address. Things, of course, like precise movement of the picker arm, the storage and retrieval of the work pieces from the shelves, and so on, because, of course, it's all you've got to get it in just the right spot. So, of course, you need to have a lot of precise programming. Dimensions for this model are approximately 19 by 28.5 by 15 inches, and it has a weight of 18 pounds total. Again, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you do need to provide your own PLC and programming. And in this case, there is a limited release 9-volt version available, which ships pre-wired to the pre-programmed TXT controller, and one 120-volt power adapter is required with that. The next model we're looking at is the multi-processing station with oven. Now, the model you're going to see here features a furnace simulation with a pneumatic sliding door. There's a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components on this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of about 11 pounds. Again, it's available in both the 24-volt version for use with the PLC of your choice, with, once again, a relay board for motor polarity reversal, and both the multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. The 9-volt version in this case is connected to 2 Robotics TXT controllers, so in this case, 2 120-volt power adapters will be required for all operations. We're going to just let them continue again for a couple more seconds here so you can see the rest of this play out. And there you go. The next model we are looking at is the sorting line with color detection. We'll just turn that off. It likes to start without me. The simulation you're going to see here features a system for detecting work pieces of different colors, and it sorts them via a conveyor belt into 3 different storage bins. Components on this model include 2 mini motors, 5 photo transistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of just about 10 pounds. Now, as before, the 24-volt version has a relay board for motor polarity reversal, and both a multi-pin connector, in this case 34 pins again with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And again, the end user must provide the PLC in the program. The 9-volt version again comes pre-wired to a pre-programmed TXT controller, and one 120-volt power adapter is required for that. We'll let the pieces sort through, and we will move right on. And there we go. So the next model we're looking at is the factory simulation, which combines the last four models that we just reviewed: the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with color detection, combines them into one self-contained material cycle. What you're going to see in the following video is this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot, and then are moved to the multi-processing station with the oven. After the work piece has been processed by the oven, it is then sorted by color in the sorting line with color detection, before again being moved by the vacuum gripper robot to the automated high bay warehouse, once again for storage. Now, as we've already discussed the components of each of these models previously, I'm not going to belabor it by restating them here, but what I do need to mention are the dimensions of this model as a whole. As you see, as it combines four individual models into this one cycle, it also has a much larger footprint. In this case, it's approximately 39 by 31 by 16 inches, and it has a total weight of between 43 and 46 pounds, depending upon whether we're talking about the 24-volt version or the 9-volt version because of some of the components. Now, due to these dimensions, please note this model can only be shipped flat as freight on a pallet. And I also want to point out that as the factory simulation models do tend to be in high demand, please anticipate, if you're going to order these, please anticipate you could be looking at a 2 to 3 week turnaround prior to any orders for this model leaving our warehouse. And that's again because there is high demand for these, and also for the other versions we're going to be looking at a little later, the IoT versions. And there we go. Now, the next thing I want to touch upon before we look at the next group of models, I want to mention that there is a storage option available for those users of either of the two factory simulations that I just discussed who want to transport the model or who want to protect it when it's not in use. Now, this travel case consists of an aluminum casemaker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories, things like the work pieces for the warehouse and what have you. The lower portion of the case is lined with hard foam, and it's designed so that once the top of the travel case is removed, the model itself can remain in the bottom section of the case and be fully functional. The case itself has exterior dimensions of approximately, 41 by 33 by 17 inches, and it has a total weight of about 53 pounds. So keep in mind, if you have the 53 with this and the roughly 46 pounds of the model itself, you're looking about 100 pounds when this is loaded. Now, please do note that even when using the travel case, these models will still need to always be shipped flat, always be shipped on a pallet, because of course you want to protect them from any kind of damage in transit. The last group of models that we're going to look at focus specifically on the area of IoT, and these are called Training Factory Industry 4.0. Now, this model concept was designed to help address how the recent changes in industrial production, which of course were driven by digitization, have created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before, of course, they're implemented on a larger scale. Now, as the following video does provide a nicely narrated overview of just how the factory works and walks you through everything, I'm going to step back for a moment and allow you to listen to the narrator and watch. So here you go.
Fisher Technique Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The training factory industry is controlled by a PLC controller, a Raspberry Pi as IoT gateway, and a TXT controller. The PLC program controls the individual modules of the factory. The program is written in structured text. The PLC communicates via the standard OPC UA protocol with the Raspberry Pi, which acts as an IoT gateway to connect the factory to any cloud. The program on the Raspberry Pi is implemented in Node-RED. In Node-RED, there is an additional local dashboard available, which can be adapted to your own needs. The Raspberry Pi also communicates with the TXT controller via the standard MQTT protocol, which in turn enables access to the Fischer Technique Cloud. The program on the TXT controller is executed in CC++. The sensor image data are used and monitored in the Fischer Technique Cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The first-in, first-out principle applies to outsourcing. The goods that were stored first are also the first to be removed. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. The production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. The Fischer Technique Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
Now, as the video just touched upon, the following topics can be addressed with the Fisher Technic Training Factory Industry 4.0. Training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, the linking of production and materials planning data, the connection of upstream and downstream logistics processes, and for experts, the creation of your own unique programming using C, C++. Now, as you just saw, the model incorporates many features not found in the models that we previously discussed, perhaps most notably, the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which helps collect data on variables such as temperature, air quality, humidity, and air pressure. Again, the use of NFC chips in each individual workpiece enables the position of each workpiece in the work cycle to be mapped. And the use of MQTT, or message queuing telemetry transport, that allows the network TXT controllers to communicate with one another. And just to talk about some of the differences, we're going to begin by focusing on the 24-volt version and what makes it unique. First off, it's a bit of a hybrid in that while requiring a PLC for operation and control, it also incorporates one Fisher Technic's Robotics TXT controller. Now, in this case, the TXT controller serves as the MQTT broker and interface to the Fisher Technic cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, which is also known as OPC Unified Architecture, is a standard for exchanging data across different platforms such as this. In addition to the TXT controller used here, there is also an IoT gateway using Raspberry Pi with Node-RED. And this allows the option for not only presenting and using data on a dashboard in the Fisher Technic cloud, but also being able to display data and calibrate the stations of the factory in a Node-RED dashboard. The model also incorporates newly developed 24-volt adapter boards to interface with the PLC. And these, of course, ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows for the speed of the encoder motors to be controlled via PWM or pulse width modulation. And they also have push-pull output stages for phototransistors and for buttons. But what is probably the most important new feature, unlike the previous 24-volt models that we've discussed this afternoon, the new 24-volt Training Factory Industry 4.0 includes access to a sample program. Now, this sample program is created in structured text format, and it was designed around a Siemens S7-1500 PLC. And the program itself is available for free download on GitHub. Of course, the new Training Factory can also be controlled with other PLC models besides the Siemens and other brands. Once the end user makes some small adjustments to the sample program, you can do that. And of course, all of the source code needed to do this is all available also for free download from GitHub. And you can get all of this information and much more in the 152-page manual that accompanies the model, and it should also be available on our website for download. You can also email me for that if you would like to look at it. I'll give you that information at the end. Now, in the case of the 9-volt version, the control is facilitated through the use of 6 Robotics TXT controllers. And unlike all the other 9-volt versions that we looked at previously today, in this case, they're programmed not using RoboPro, but instead using C, C++. In this case, all the programming is preloaded so that once the connections to the internet and the cloud-based dashboard are made, all of which are clearly outlined in the downloadable documentation PDF. Once this is done, you should be able to get started very quickly. The 9-volt version will require the addition of 3 120-volt power adapters. It must also be stated that whether we're talking about the 9-volt or the 24-volt versions, it is also required that the end user, of course, has the ability to access the internet, as well as a tablet or a device for accessing the cloud-based dashboard. And just to finish things up, the dimensions for these models are approximately 39 by 31 by 16 inches, and they have a weight of approximately 51 to 53 pounds, depending on the version again. And as with the 2 factory simulation models we discussed previously, we do recommend the optional travel case to help protect your model during travel or even just during storage. And that's the Training Factory Industry 4.0 model, which again is available in both a 9-volt and a 24-volt version. We do have one more model to talk about today, though, and this was just added to the Fisher Technic simulation line in late spring of this year. This model, which is, of course, the new quality control with AI, incorporates the cutting-edge technology that is quickly becoming a part of our lives. It's ideal for visualizing this complex subject area in a very hands-on manner, as it creates a sustainable learning experience by linking theory and practice. Processes can be sped up, fault rates and costs minimized, and fault evaluation standardized. This Fisher Technic sorting line comes with workpieces in 3 different colors. These workpieces are marked with 3 different processing characteristics, as well as with various fault patterns. You see some examples on the screen here. The workpieces get scanned by the camera, and they are classified with the aid of the trained AI. Now, depending on the color feature and the fault pattern, the workpieces are then sorted by the artificial intelligence on the basis of their quality features. The AI used is realized with machine learning in TensorFlow, where an artificial neuronal network was trained with image data. The learned AI is executed on the Fisher Technic TXT controller, and the model sequence control is implemented in the RoboPro coding programming environment and in Python. Now, if you want to go a step further, you do have the option of generating your own AI applications, and the training is done in Python, for which a sample project is provided for explanation. And that is the new quality control with AI model. Ideal training, simulation, and demonstration model for education and research and the visualization of AI systems, machine learning, and neural networks. This is currently only available in a 9-volt version, but a 24-volt version is planned for later in the fall. The 9-volt version, in this case, uses the Fisher Technics Robotics TXT 4.0 controller, and is before a 120-volt power supply is required for operation. Details and pricing for the 24-volt version are expected very soon, and again, we anticipate a late fall 2023 release. So, of course, you might well be wondering how much do all these models we've been discussing cost. So we're going to take a quick review of everything we've looked at, along with the pricing for each of the options. First off, we're going to look at the conveyor belt. The 24-volt version is $324.95 per model, and the 9-volt version is $518.95 per unit. The punching machine with conveyor belt in the 24-volt version is $419.95. In the 9-volt version, it is $599.95. Again, that comes pre-wired to the pre-programmed TXT controller. The index line with 2 machining stations in the 24-volt version is $1,129.95. The 9-volt version, which does have 2 TXT controllers, is $1,394.95. Not 13,000. Sorry to scare you. The 3D robot in the 24-volt version, that is $999.95. The 9-volt version is $1,369.95. The vacuum gripper robot, only available in a 24-volt version, it is $1,129.95. The automated high bay warehouse in the 24-volt version is $1,369.95. And in the 9-volt version with a TXT controller, again, pre-programmed, it is $1,318.95. The multi-processing station with oven in the 24-volt version, $1,199.95. In the 9-volt version, $1,474.95. The sorting line with color detection in the 24-volt version, $1,049.95. In the 9-volt version, $1,128.95. The factory simulation in the 24-volt version, $4,829.95. In the 9-volt version, $5,239. The Training Factory Industry 4.0 24-volt version is $8,999.95 per unit. The 9-volt version is $9,024.95. And there are now two special versions of the Training Factory Industry 4.0, which are available. These are both 24-volt version. There is one that includes the PLC connector board. And what this is this is the board that actually the PLC itself plugs into. It includes all the wiring that has to be done from the model itself to the PLC connection board, which normally would be the responsibility of the end user, as with any of these 24-volt versions. In this case, you get all of that wiring done for you. It is a meticulous job, so having that all done is very much very worthwhile. And again, that comes with the PLC connection board. It also comes with the 24-volt end of the power supply. You will still need a power supply for the TXT controller on there, but the 24-volt power supply comes with that. That is $12,079.95. There is also a final version that includes pretty much, it's as close as you get to having everything ready to go. In this case, it is a version that is pre-wired to a Siemens PLC. That's the S7-1500 PLC. That comes with the programming, of course, which we just discussed before. The education version of that again has the wiring, the 24-volt power supply, what have you. So that's pretty much everything you need there. The educational version is $18,499.95, and the commercial version is $20,124.95. Other items that we touched upon, the 120-volt power adapters for use with the 9-volt models are $12.99, and the travel and storage case for the factory simulation, the Training Factory Industry 4.0 models, that's $1,524.95 per unit. And also, I was worried that I had left this slide out. The quality control with AI, the 9-volt version, that is $2,089.95. Again, that comes with the TXT 4.0 controller, pre-programmed. You do need a power adapter for that. The 24-volt version, we expect to have more information on and pricing in later this fall. So at this point, if there are any questions, this is where we would normally open it up to the chat windows and what have you. I see we're having some glitches, so that can't be done right now. So I'm just going to tell you how you could address any questions you have. If you would like to, let's say, request a full color brochure with the current pricing, if you'd like to ask any questions directly, if you'd like to request a quote for any of these models, or if you would like to speak with your dedicated educational representative for your state, if you'd like to do any of this, you can call us directly here at Studica US. Our number toll free, of course, is 888-561-7521. For any of these quotes, general information, what have you, have any questions about any of this, you can email us at info@studica.com. Or if you have any questions about anything I discussed specifically today, any aspect of anything Fischer Technic related, whether it's something I touched on today or something that has to do with the greater Fischer Technic line, if you'd like to again, obtain copies of the brochure or find out where some of the things that I mentioned are located on the website, you can email me directly. My email address is lance.zurek, that's lance.zurek @studica.com. So on that note, I would like to thank you all very much for taking the time to attend today's presentation. I hope you have a great day, and we look forward to hearing from you soon. Take care.